Welcome to our supplement section on factoring. This is something that we will definitely want to master before we move into our polynomial functions and using those things to graph. And so factoring is an important concept in which you are basically undoing your multiplying of polynomials, otherwise known as FOIL, whenever you end up having two binomials. Or also you can think of it as that you're undoing the distributive property in a sense as well. So just like factoring numbers, we can break down polynomials into products. So for instance, just looking at numbers, if I say what are factors of 15, you would tell me 5 times 3 or 15 could also equal 1 times 15. So you can break a number down into its multiples of factors. So we also can do that with polynomials. So if I look at x squared minus 4, and we're going to go over this method here in just a minute. If I were to look at multiplying x plus 2 times an x minus 2 by using FOIL, my first term there is an x squared. My outside term there is a minus 2x. The inside term is a positive 2x. And the last term here is a minus 4. Now, why does that undo that foiling for this x squared minus 4? But these two things end up canceling, leaving me with x squared minus 4, which is what I started with back over here. So these would be the two factors of that polynomial. And that's what we're going to use. That's kind of the type of thing that we're going to do in this section, is to undo that multiplying. So sometimes, though, those things can't be factored. Those are problems that we end up calling prime polynomials. You don't see that often, but there are sometimes when you might have one that does not break down. Now, another thing is also these types of things inside here, these factors, anytime you have a power of 1, that is a prime polynomial. It can't go further than what you have already. Okay? Now, in order for a polynomial to be factored completely, then our polynomials have to be a product of factors which are prime or irreducible. So you're going to end up with these power of 1s, or if there's a power of 2 or higher, that is something that it cannot be broken down further. And we'll see a couple of those. Now, we're going to start with our very first rule of factoring, and that is to take out any common terms. Now, in order to take out common terms, you must determine the greatest common factor of your terms in your polynomial. And that's what could be hard a little bit sometimes, okay? That's what it's hard to see for some students is to what is the highest thing that I can take out that's common to all. So let's take this example here at first. 16x minus 24. When we ask for the greatest common factor, I'm looking at this term and this term in order to determine what that is. So if I think about the numbers, 16 and 24, what's the highest number that will go both into 16 and 24? Well, I'm hoping that you're screaming at me that it is the number 8. Now, 4 will work, 2 will work, but those aren't the highest. 8 is the number that is the highest of all of those. So, what about our variables? Well, notice on this first term I have an x, but in the back term I don't have an x. Therefore, it is not part of my greatest common factor. So, once we have determined what that is, I need to take that out front completely, and I need to determine what's left over. So, a couple ways you can do that. You can divide 8 into that 16x and get what's left over. Or you could say, what do I multiply 8 by to get 16x? Well, I need a 2 in order to make the 16, and then I need to attach the x there with that. Minus, what do I multiply 8 by to get 24 back? Well, that is a 3. So, again, you can take 24 divided by 8, however that you'd like to see that. But you can always check your work by distributing what you took out through and see if you get what you started with. And in this case, 8 times 2x is 16x, and 8 times a negative 3 is a minus 24. So we have accomplished what we set out to do, okay? All right, so let's look at the next one. The next one has 8x cubed minus 4x squared. So between this term and that term, let's take our numbers first, then we'll take our letters. So between 8 and 4, we're looking at factors of those. That is the highest of each in each of 8 and 4. So if you think about 8, I get that often, but 8 does not go into 4 evenly. So thinking about 4, the only factors of 4 are 1, 2, and 4. Which ones of those will go into 8? Well, actually, all of them will. So 4 is the highest. So for our GCF, we need 4 for our number. And then I have x cubed and an x squared. So we do have an x in common. Now, how many do they at least have for each term? Well, one has 3 and one has 2. So they have at least 2 in each term. So 4x squared is going to be my GCF. So when you have a variable, you want to take the lowest power is what's common to each, okay? Take the lowest power out. All right, so if we're going to take out a 4x squared, and again, we have to ask ourselves, what's missing? What did I leave behind when I took out 4x squared? So 4 times what is 8? Well, that is a 2. I have 2 x's here. I need 3 x's by that power. Therefore, I need 1 more left over. So again, 4x squared times 2x does give me that 8x cubed. Minus, what do I multiply 4x squared by to get a 4x squared? Well, this one's a little ambiguous and it's a little bit tricky, but you still have to have a kind of, in a sense, a placeholder there. Now, I took both terms out. So I took the 4 out completely. I took the x squared out completely. So it's not like I'm left with nothing. I'm actually left with a 1. 4x squared times 1 gives me 4x squared. So you want to make sure that you include that if that is the case where one term is your greatest common factor. All right, let's move to the next one. The next one ends up having negative 2x to the 5th plus 6x to the 3rd. So I need to take out common terms between each one of those. Now, between 2 and 6, the greatest common factor is going to be 2. And with my powers, I have x to the 5th, and x to the 3rd. So I'm going to take out my lowest power. So I need a 2, x to the 3rd. But also notice this time I have a negative up front. So I'm going to show you how that works. So because sometimes you do have to take a negative out. So I'm going to take out a negative 2x cubed because what's inside here, normally that first term we want to be positive, okay? So negative 2x cubed times what gives me a negative 2x to the 5th? Well, here's my negative 2 completely out. I have 3 x's here. I need 5 x's, therefore I need 2 more to make that x to the 5th. And if I take a negative 2 out, that means that the sign of this is going to change. See, this sign became a positive. It was originally a negative, and it became a positive. Now, if this is a positive, negative 2 times what is a negative, or a positive 6, and that is a negative 3. So it changes the sign anytime that you bring a negative out. So negative 2 times negative 3 gives me a positive 6. And I brought x cubed out front, which is how many that I had back here. So this should be my final answer. Go ahead and distribute. This times this gives me my negative 2x to the 5th. And negative 2x cubed times a negative 3 does give me my positive 6x to the 3rd. And that would be my final answer. Okay? All right. Last one of this, of common terms. Everything that we'd seen before, this one was just a number. This one has a number and a letter. This one has a number and a letter as well. That is common to each one of those. That is the greatest common factor that I have for those polynomials. Now we turn to this last one, and I see 2 terms. I see this term, and I see that term. But in this sense, I do not see a common letter per se, with a power in common. What I see, hopefully, is what's inside those parentheses that is common to both. So I end up having an x minus 7, an x minus 7 that is common to each one of those 2 terms. And so notice, I'm going to take this x minus 7 out front because it has the same in each. It is common to both. And then I need to figure out, well, what is left over? So x minus 7 times what gives me 2x times x minus 7. Well, this was already accounted for, so I'm leaving behind that 2x. and an x minus 7 over here was brought out front. Therefore, what am I leaving behind? What do I multiply that by to get this back? Well, it is that plus 3. So you'll see a pattern going along with a lot of these factoring problems. And the pattern for this one is if I get rid of this and I get rid of that as my common term, what's left over is what's inside or what's in front of those parentheses for my final answer. Okay? All right, that last problem there leads us into our next little section about grouping. When you are factoring, you need to be conscious of how many terms that you have in a polynomial, because that's going to decide the strategy in order to solve your problem. So the first problems that we just did were ones that had common terms. So that's something that you need to make sure that you look at every single time when you start a problem. Now, once we have that done, any common terms taken out, there might be a chance that we go further, in a sense, with what's inside there. But this time we have a 4-term polynomial, okay? So this, if you count the number of terms that you have left behind, and it is 4, then you're probably going to use a strategy which I refer to as a 2-by-2 grouping, okay? So notice this next example that I have here. X cubed minus 3x squared plus 4x minus 12. That is a 2-by-2 or a 4-term polynomial that I'm going to try to factor with 2 and 2. So grouping 2 terms together. Now, hopefully those 2 terms end up having something in common. That is what our strategy is going to be. Once grouped up, one will need to take out the greatest common factor out of each group separately. So that's what I mean here on this term. We're going to look at what is common with these 2 terms. Well, notice there's a 1 in front. Therefore, there's not going to be a GCF because taking a 1 away from that doesn't make anything simplify. It would just stay the same. So here I'm just looking that there is an x squared in common. Now, what's left over when I take an x squared away from x cubed? Well, I took 2 away, therefore I'm left with 1. And here I've taken an x squared out, leaving me with this minus 3. So that's, again, looking at taking out common terms. Now, what is common with these 2 terms? These 2 terms, they both don't have a variable, so we can't take any variables out. But I do end up having a number that is in common. And that number, the greatest of those numbers, would be 4. So I need to take out a positive 4 just from these 2 terms. So 4 times what gives me 4x, and that is going to be an x, and positive 4 times what is a negative 12. Well, that has to be a negative 3. Now, it's very nice that I have these 2 expressions that are in common because that's what's happening. When you're grouped 2 by 2, you want the expression to be in common. So since now this term and this term, I have an x minus 3 in common, I'm going to take that out and be left with what is in front of those parentheses. So x squared plus 4 gives me my final answer. So that was very similar to this problem that we had up here in our previous section, the very last one of that. Okay? All right, let's try this next one. The next one has 1, 2, 3, 4 terms. Notice all of them don't have a letter, so there's nothing in common with all. And here I have a 1 in front, therefore there's not a common number with all 4 terms. So my strategy is going to be looking at a 2-by-2 grouping and see what is in common with both of these. Well, in this case, I have an x squared in common, just like before. What do we multiply an x squared by to get an x cubed? It is an x. And what do we multiply x squared by to get a positive 5x squared? It is that plus 5 left behind. And so, again, with a 2-by-2 grouping, we want a common expression. So my mind is thinking, okay, I need an x plus 5 from these 2 terms back here. Now, notice that each of them, if these are both positive, each of these are negative. So we're going to take the strategy that we did here in this third example up right above, where each of them have a negative. So I'm going to take a negative out of both, and also they have a common 2. 2 can go both into 2 and to 10. And that's what I need to look at now, saying, okay, if I took out the negative 2 away, what's left over? Well, in that case, it is just an x. So negative 2 times x gives me negative 2x. That's good. Negative 2 times what gives me a negative 10? Well, if you think about dividing these two, you can. The double negatives end up changing the sign to make that a positive 5. So double check, negative 2 times positive 5 definitely is negative 10. So therefore, between this term and this term, remember they are separated by a minus. I have a common expression. I have an x plus 5 in common. So I have x plus 5 that I would bring out front. So if this is gone, what am I leaving behind? It is that x squared. And if this is now gone, what am I leaving behind? It's what's in front, and that would be a minus 2. And that would be my final answer there for that 2 by 2 grouping with a 4-term, excuse me, polynomial. Okay? All right, very good. Now, let's get into our first special case. So actually, first rule of thumb is to look at common terms. Then we're looking at special cases. This 4-term polynomial would be a special case. And then we're going to turn our attention to a 2-term polynomial that is referred to as the difference of squares. So what do you get when you FOIL a plus b times an a minus b? Well, let's look at that. If I were to FOIL that, I would do a times a, which is a squared. Outside gives me an a times a positive times a negative is a minus. A times b is ab. Inside would be a positive. Now, don't write it as ba, write it as ab, alphabetical, so you can see common terms. And then our last term here, a positive times a negative is a minus, and a b times a b gives me a b squared. Now, if I look at these 4 terms here, those 2 things are going to go away, leaving me with a squared minus b squared. That's what I get when I FOIL that a plus b times an a minus b. So, the difference of squares that we will use quite often says that if I end up having a difference of 2 perfect squares, a squared and b squared, then I can factor it into 2 binomials where each of the terms are exactly the same, except for one is a plus and one is a minus. Or you can do the minus and then the plus if you so choose. It doesn't matter the order. But you ask yourself, what did I square to get an a squared? It's an a and an a. What do I square to get a b squared? It's a b and a b. That's what goes in those polynomials, okay? All right, so let's look at this first one. This first one, notice that we do not have any common terms. There's not a variable back here. There's not a number other than 1 up here, so we don't have anything in common. But it is 2 different terms that are separated by a minus. This is a perfect square. Any 2, 4, 6, 8 power, any even power is going to be a perfect square. And 81 is a perfect square. You need to ask yourself, what do I square in order to get 81? That one is actually 9. So this difference of squares is going to factor into 2 binomials where one's a plus and one's a minus. I'm going to split this x squared up because what do we square in order to get an x squared? It is an x and an x. And what do we square to get an 81? Well, that is a 9 and that is a 9. And this is completely factored. Again, once you have values or polynomials that have powers of 1 inside there with your factors, you can't go any further. So that would be all complete. Okay, now do I have any common terms with 36x squared minus 25y squared? The answer is no. There's no common terms there. But I do have 2 different terms. Check to see if it's a difference of squares. Well, I have the minus. That's good. This is a perfect square. Actually, the letters are perfect squares because they are even powers. 36 is 6 squared and 25 is 5 squared. Therefore, these are perfect squares. So I can factor it into the differences of squares where one's a plus and one's a minus. Ask yourself, what do we square to get 36x squared? Well, we need a 6 and we need an x. So each term gets a 6x. What do we square to get a 25y to the second? That is a 5 and a y. A 5 and a y. Make that a better 5. Okay? And so that would be your final answer. Again, powers are 1 once I break that down. Therefore, I can't go further with that anymore. All right, the last one on this page, we have an x to the 4th minus 81. Notice there's nothing in common. Number 1 in front, no x back here. Therefore, I look to see, is that a difference of 2 squares? Well, we already talked about 81 being a perfect square, but x to the 4th, since it's an even power, we can, in a sense, break that up evenly into my 2 binomials. One's a plus, one's a minus. So, if I have x to the 4th, I need x squared and x squared. We're going to split it up evenly. Just like with our x squared, we split it as an x and an x. Now, what did we say? We said we squared 9 to get 81. And so I end up having this as the first time of factoring. But we have to be cautious to make sure that we can't go further. So if I look inside here, there's powers of 2. So I have to be cautious and double check. Can I go further with that? Well, notice here, there are 2 terms. Nothing is in common. I have a plus between them, so there's no way it could be of this special case of a difference of squares. So this, when you have, this is what we refer to as a sum of squares, it will not go further. So I'm going to rewrite that. But when I turn to my second set of parentheses here, notice I have nothing in common, but I have a difference of 2 perfect squares. This is a square, and I square 3 to get 9. So I can actually go further with this, which means I have to split it into 2 binomials again. Just like what I did over here when I had x squared minus 81, I can continue to do that when I have my x squared minus 9. So a difference of squares means that one's a plus, one's a minus. They each have the same exact things inside. So what did I square to get an x squared? It is an x and an x. What do I square to get a 9? It is a 3 and a 3. And that is my final answer. If I were to FOIL those all together, you have to do it in 2 steps, you would end up getting x to the 4th minus 81 as your final answer. Okay, so you can always, always, always check your work in these types of problems. All right, very good. Let's move on to 3 terms. We've done 4 terms. We've done 2 terms. Now we get to do 3 terms. And I usually refer to this as trial and error. I will tell you there are multiple ways in order to factor polynomials, but in my years of experience, this is the way that I have found that students are the most successful with that, okay? So it's a part of a pattern work, and it's part of being able to practice and to master that concept. So you might have to do multiple ones of these in order to get the concept. So factor 3-term trinomials by trial and error. Now, in order to factor the trinomials, you must know the following. Now, trinomials means I have 3 terms here. 1, 2, 3, separated by the pluses or the minuses. 1, 2, 3. So these are going to factor into 2 binomials, always. Okay? So that means you're going to have 2 parentheses with 2 terms in each. Now, it is very important when we are doing this by trial and error that you know the rules of the signs. The signs inside your 2 binomials are as follows. If the last sign of your trinomial is a plus, then the signs are the same that match the first. So for instance, in this example that we're getting ready to do, it's a trinomial, nothing in common, there's no x's in common, there's no numbers in common. If the last sign is a plus, they are the same that match the first. So that means inside here I need a plus and a plus. Okay? If the last sign of our trinomial is a minus, then the signs are different. So I have 1 plus and 1 minus inside my binomials. So look at this polynomial here. It's a 1, 2, 3 trinomial. I have nothing in common. This doesn't have an x, nor does this have a number in front. So no numbers or x's in common. So if it's a trinomial, it will factor into 2 binomials. Since the last sign is a minus, the signs are different. So I'm going to put a plus and a minus. So that's going to kind of prep us. Now, once we get to that point, we're going to work with these factors, okay? You basically have to split up the first and the last terms in here, and we're going to figure out to make sure that that FOIL works. And the last reminder here is you always can check your work to make sure you got the right answer. All right, very good. So when we FOIL, this x squared always comes from the first term. So we're going to break up x squared and we're going to break up 40. We're going to use the outside and inside to make sure we get our 13x. So if I have x squared, that means I'm going to split that up evenly as an x and an x. Now, with these 6 problems, I intentionally put a 1 in front of each one of these because these are what we sometimes refer to as easy factoring, because there's a nice little question we could ask ourselves that helps us out get our factors. So with 40, there's all kinds of factors. 1 and 40, 2 and 20, 4 and 5, I believe are all the ones. So, oh, not 4 and 5, sorry, 4 and 10, I was thinking 20. 4 and 10 would be 40, and then 5 and 8 would be 40 as well. So there's kind of 4 sets there. But when we have a 1 in front with our easy factoring, here's the question that we can ask ourselves. What do we multiply to get 40 that I add to get 13? Let me say that again. What do I multiply to get 40 that I add to get 13? Well, of all those factors that I said, 1 and 40, 2 and 20, 4 and 10, and 5 and 8, hopefully you're screaming at me that it is a 5 and it is an 8. And that would be correct. Now, I could have put an 8 here and a 5 here. That would have worked too. But now that I FOIL this, x squared, outside is 8x, inside is 5x. The last term gives me a 40, and that 8x and 5x combine to get the 13. These are your factors. Okay, let's try that again. If I have a trinomial, it's going to factor to 2 binomials. There's nothing in common here with these. We have a 1 out front, no x on the back to have anything in common. Last sign is a plus, so they are the same that match the first. So we're going to go a plus and a plus. We're going to break up the x squared to go in the first terms. We're going to break up the 15 to go in the last terms of each. Okay? So the x squared is very nice. If you just have an x squared, you just plop an x in each one of those parentheses. And now here's our trick. Here's our question that comes up and says, what do I multiply to get 15 that I add to get 8? What do I multiply to get 15 that I add to get 8? And again, I hope you're screeching 5 and 3 at me. And again, you could put the 5 here and the 3 here, or the 3 here and the 5 there. It does not matter because your multiplication is commutative. Okay? All right, very good. Next, trinomial, no x in all, no number in all, because I have a 1 and at least 1. I'm going to factor to 2 binomials. I'm going to check my signs. Well, the last sign is the plus, so they are the same that match the first. This time I have double negatives. I see in the front that it is just an x squared, so I'm going to split that up as an x and an x. And now I'm going to ask myself the question, what do let me change my colors real quick here. What do I multiply to get 16 that I subtract to get, that I add to get 8? Let me say that again. What do I multiply to get 16 that I add to get 8? Well, in that sense, we have 1 and 16, 2 and 8, 4 and 4. When I add each one of those, the ones that add to give me 8 are 4 and 4. Now, collectively, I want you to look at that and say, oh, well, look, I have an x minus 4 and an x minus 4. So that would be an okay answer, but also I would accept x minus 4 to the second power, considering that is what I could do to combine that together. And you'll see that that'll be beneficial later on when we get to our polynomial graphs. Okay, so this is also sometimes called a perfect squares trinomial. I don't ever really teach it that way as a special case because it can work itself out just like it did here with our trial and error polynomials, okay? And it's one less thing that you have to remember as a special case. All right, let's try this next one. We have a 1, 2, 3 trinomial, nothing in common. But this time we also, when we are talking about our signs, see that the last sign is a minus. Therefore, we have a plus and a minus. What do we do to get our first terms and our last terms? Well, the first terms come from x squared, so I'm going to plop an x and an x. And my last terms come from factors of 14. So when I'm looking at factors of 14, I'm looking at, okay, what do I multiply to get 14 that this time I subtract to get 5? What do I multiply to get 14 that I subtract to get 5? Well, 1 and 14 gives me 14, but when I subtract, I get 13. 2 and 7 gives me 14 as well, and when I subtract from there, I do get a 5. Now, here's where you have to be extra cautious of the sign in front of that middle term. We need to force that to be a -5, not a +5. So if I do a -7 plus a 2, because those are my factors of 14, when I do my outside and inside, I get a -7x plus a 2x, which gives me a -5x. And that's what I want. Now, don't put a plus here and then a minus there, because you would end up with a +5 instead of a negative. So make sure when you have signs that are different inside that you really work on getting the correct sign on which number. Okay? All right, here's another trinomial be factored into two binomials. Nothing in common. This time I have a minus, so again, it's going to be a plus and a minus. The signs are different. We have an x squared, so we're going to plop an x and an x. And then we ask ourselves, what do we multiply to get 5 that I subtract to get 4? Well, 5 is a very nice number because it's prime. The only factors are 5 and 1. And so notice we need a -4 here, so I need a -5 plus 1 will give me that -4. So if you have to FOIL or just do the outside and inside terms to verify that that is correct, please do so. All right, and our last one like this, we have two. If you want to pause this and try this one on your own, that would be a good thing. Or we can just barrel through that. Notice the last sign is a minus, so they are different inside. So we have a plus and a minus. Again, we have a 1 in front of our x squared, so I got to split up this x squared, and we can ask that wonderful question, what do we multiply to get 21 that I subtract to get 4? Well, the only factors for 21 are 1 and 21, 3 and 7. Subtract these, I get 20. Subtract these, I get 4. Now, what do I need this time? I need a +4, so I need a positive, the larger number, +7 minus 3 to give me that +4. And these are your two factors. Okay. All right, very good. Those 6 examples are ones that have a 1 in front. And those are the ones that are very nice to be able to factor because you can ask that wonderful question. The next 3 are ones that we are going to have to really do a trial and error. So if you're not working with a pencil, this is the time that you start working with a pencil because you might not get the right order the first time. All right. We'll be looking at trinomials which have a coefficient other than 1 in front. So notice we have a 6 in front, a 9 in front, another 6. Make sure to always check the outside and the inside terms of FOIL to confirm or verify that you have the correct factors. So 3 terms, just like before. We have a trial and error situation, but this time we want to make sure that we be cautious of each of the front and the last. Now, the signs are exactly the same. If the last sign is a minus, they are different inside. One's a plus, one's a minus, and I'm just throwing them in. I'm not sure if I have them in the right spot. I need to look at factors of 6x squared. Well, obviously with the x squared, I'm going to need an x and an x. But let's look at numbers of 6 that I want to use. Factors of 6 are 1 and 6 and 2 and 3. And I will tell you, I normally start with the 2 that are closer together on the number line. So I'm going to throw a 2 here and a 3 here. Again, I don't know if I've put them in the right spot. We are just doing some trial and error. Now, the last 2 factors have to come from the last term. So the only factors of 7 are 7 and 1. So I'm going to, again, plop a 1, plop a 7. I don't know if I've put them in the right spot, but I now need to check the outside and inside of FOIL to see if I do have it correct. So outside gives me a -14x. Inside is a plus 3x, and what I'm looking for is a positive 19. Well, unfortunately, that gives me a negative 11x. That is not what I want, okay? All right, now, since that is incorrect, I'm going to get rid of this, start over, and this is where your pencil eraser comes in. I'm going to switch one of them, okay? So I'm just choosing the 1 and 7 to get away. You can switch the 2 and 3 if you want, okay? So I had a 7 here before, so I'm going to put the 7 here and a 1 here, okay? Now I'm going to check the outside, which is a minus 2x, and the inside, which gives me a 21x. which actually gives me what I want. That's the positive 19x. And again, you got to be cautious of that sign. It is a positive, and that's what we need, okay? Now, I'm going to, so these are my two answers, but I'm going to talk about what if I were to go in here and I ended up having my signs like this, okay? Where I have this one to be the minus and this one to be the plus. Now, down here, this would have been a plus 2x and a minus 21, which would have given me a negative 19x. Now, in my problem, I need that to be a positive. But it's very nice when you get the number, when you do the outside and inside check. If you get the right number but the wrong sign, that is good because the quick fix is you have to change your signs. Make that a plus, make that a minus, and you have your factors. So be very, very cautious of the signs on each of these so that you get them correct. Okay? All right, so 2x plus 7 times 3x minus 1 is my final answer there. Let's move on to the next one. The next one has 9x squared minus 12x plus 4. Trinomial. There is nothing in common with my numbers. All of them don't have an x, so therefore I can go straight to two binomials. Last sign is a plus, so they are the same that match the first, so a minus and a minus. And we're going to look at factors of 9x squared. Well, the factors of 9 are 1 and 9 and 3 and 3. Again, I try to start with the ones that are closer together, if not equal. And then we have an x squared, so we need an x and an x. Now again, from the back side, what are factors of 4? 1 and 4 and 2 and 2. I'm going to, again, start with the 2's and 2's just to see if that works. Now, how do we verify? We check the outside and inside. So you can do this mentally, or you can actually just write it on your paper. That's fine. 3x times a negative 2 is a minus 6x, and inside here is a minus 6x. That gives me a minus 12x, and is that what I need in my middle term? Absolutely. So we have found exactly what we need as our factors. Now, you might say, hey, that looks the same. Those are exactly the same. Can I write that as 3x minus 2 quantity squared? And the answer is absolutely you can. I would actually prefer it to be that quantity squared if you recognize that. Okay? All right, and our last one of these with our trial and error. Let's do that. 6x squared minus 17x plus 12. 17 is a prime number, therefore there are no numbers in common, and not all of them have letters in common. So there's nothing in common. We will go directly down to two binomials. Last sign is a plus, so they are the same that match the first. Again, we have a minus minus. And I'm going to look at factors of 6, which, again, 6 we looked at over here, 1 and 6, 2 and 3. So I'm just going to plop a 2x and a 3x in. Again, don't know if I'm putting them in the right spot. And factors of 12. Well, we got many. 1 times 12, 2 times 6, 3 times 4. And again, I usually start with these ones that are closer together. Now, here's another trick of the trade. The original problem did not have anything in common. We checked that. So if that is the case, that means that your factors can't at any point have anything in common either. So if I choose this 3 and 4, if I put a 3 here, notice that 3x minus 3 would end up having a 3 in common. So I can't do that. So I'm going to tell myself, no wasting time of that, I'm going to go ahead and just put the 3 over here, because it can't be over here with this 3. Likewise with the 4, if I tried to put the 4 here, 2 and 4 have something in common, therefore they can't be there because this didn't have anything in common. So that's why we would put it over here with the 3 as a way to check to see if that is what we need, okay? So how do we check to make sure we have the final answer with the 17x in the middle? Well, the outside is a minus 8x, inside is a negative 9x, and when I put those together, ding, 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 that gives me a negative 17x. That's my middle term, therefore these are my two factors of that trinomial. Okay? All right. Here's our factoring steps I'll put together for you. Putting it all together, make sure that you can factor completely and follow these steps. Number 1, are there any common terms to pull out to begin with? Then you look at your 2-term, 3-term, 4-term cases, okay? Where we have 2 terms as the difference of squares, and actually I'm going to mark this out because we didn't go into that. We have 3 terms, which is our trial and error, and we have 4 terms, which was our 2x2 grouping that we saw on the front side. Now, remember, double check to make sure that you cannot go further after factoring one time. So, let's look at this 2-term polynomial. First thing I want to look at, are there any common terms? Well, notice 5 does go into 45, so there is a common 5, and they have x's that are in common, but remember we take the lowest power, that's that invisible 1. So I'm going to take out a 5x out front, and I'm going to see what's left over. Well, here, 5x times what gives me an x cubed? Well, I need 2 of those x's, so let's go x squared minus 5 times what is 45? Well, that is a 9, and I brought the x completely out front, so this is what we have remaining. Now, the very last statement in that box above there says to double check that you cannot go further. This is a power of 2. I have to verify that I can't keep going further. And in this case, I can because I have 2 terms here. Go up to my 2 terms special case. That is a difference of 2 squares. That's a perfect square. That's a perfect square. So from the back side, we have 2 binomials. That's the a plus b times an a minus b. One's a plus, one's a minus, and these are exactly the same. So we're going to split up our x squared as an x and x. And what did I multiply to get 9 that I squared? Well, it's a 3 squared, so 3 times 3 does give me 9. Once I get down to powers of 1s, we are completely factored. Okay? Turn to the next one. The next one has 6x squared minus 6x minus 12. And notice that there are no letters in common with all of them, but each of them can be divided nicely by 6. So I'm going to factor out a 6, but what am I left with? If I take 6 away, I leave the x squared. Take 6 away, I leave the x. And take 6 away from that, I'm leaving a factor of 2. So I get x squared minus x minus 2. And again, because I have a power other than 1, I have to ask myself, can I go further with this trinomial? And in a sense, if it's a trinomial, we're going to try our trial and error. Now, this has a number 1 in front, an invisible 1, so we can use our wonderful trick. So let's try it. Last sign is a minus, so they are different inside. Splitting up x squared, I get x and x. Ask yourself, what do you multiply to get 2 that you subtract to get a 1 that's invisible here? What do you multiply to get 2 that you subtract to get 1? Well, 2 is a prime number, therefore it is 1 and 2 are my only factors, and I need a negative 1. So I need a minus 2 plus a 1 to make sure I get that negative. Outside the minus 2x, inside the plus 1x does give me my minus 2. Powers of 1, power of 1, therefore this is my final answer, my final factoring. Okay? So those are the different techniques that we're going to use for factoring. Now we're going to actually add one little piece to that and be able to solve polynomial equations, which takes us one step further after we factor, because then we have to find the solutions or the numbers at which it makes that equation equal to 0. Now, all equations have to equal 0 before factoring. So if there's terms on one side, you got to move them all to the other side to be able to factor that and then solve. So we're going to be able to solve this by something called the zero product property. Now, the zero product property states that if I have two things multiplied together, call them A and B, and I multiply them together and I get 0, that means that A has to equal 0 or B has to equal 0. One of those has to be 0 so that when I multiply them, I get 0. And that's kind of the idea that we have when we are solving polynomial equations. Now notice these first two I'm giving to you very nicely because they are completely factored first. Solve the following equations by factoring. That means I have to get the answers that make it equal to 0. If I just say factor, then that means you can leave your answer minus this equal to 0 like this, as an x minus 5 times an x plus 1. That's what it means to be factored. Okay? Solve, we go one step further to find what makes that equal to 0. Alright, so this is what I like to do at the start, just so that you see, but we will get past this of doing a T-chart. If you like to do the T-chart all along, go right ahead. So by the zero product property, call that A and call that B. That if the product of those is equal to 0, that means that this x minus 5 has to equal 0, or the x plus 1 has to equal 0. And when I split that apart, I have two equations that I could actually solve and find out what numbers that is. So if I add 5 to both sides, I get x equals 5. If I subtract 1 from both sides, then I get x equals negative 1. Therefore, making 5 and negative 1 the solutions or the answers to that equation. Now, that's pretty simple, right? If I ask the question, what number minus 5 is 0? You would tell me 5. And what number plus 1 is 0? You would tell me negative 1. So a lot of times we don't do this piece here. That's the idea behind it, but we change, kind of get in the mentality of doing a shortcut and figuring out those without drawing like that T-chart. So if I then turn to this equation, which is completely factored, powers of 1 on each one of those, that would mean that each one of those would have to equal 0. X has to equal 0, 2x minus 1 has to equal 0, and 3x plus 1 has to equal 0. And so I could solve each one of those. Well, this one's already solved for us, okay? Anytime you have a letter out front, 0 will be an answer. Now, how do I solve for x here? Well, I want to add 1 to both sides. Then I need to divide by 2, and so I get x equals 1/2. How do I solve for x on this one? Well, I would subtract 1 from both sides and get 3x equals minus 1, and then divide by 3 and divide by 3. X has to be negative 1/3. Therefore, 0, 1/2, and negative 1/3 are my answers to that equation. Now again, we did a nice little shortcut here. What do I subtract 5 from to get 0? What number plus 1 is 0? Here, what number do I throw in there to be 0? Don't make that too hard. But when I have numbers in front, it is a little bit more confusing. But the idea is this. I'm bringing that number over by changing to its opposite, and then dividing by the number out front. So that's kind of the shortcut that we use in order to find these roots. Take the opposite of what you're looking at over the number out front. Take the opposite of what you're looking at over the number out front to get negative 1/2, positive 1/2 and negative 1/3. Okay? All day long, you can set them equal to 0 and solve, but I'll tell you, if you get used to that pattern and used to that trick, life will be a lot easier. All right, let's see what we can do to solve this equation. We're equal to 0, that's good. We need to factor. Now notice there are common terms here. They have a common a, so I'm going to take an a out front. Now what did I leave behind? A times what is 4a? Well, 4a squared. That is just a 4a because I took 1 away. A times what is a? Well, that's the exact same thing. So there's that trick again where I have to put that plus 1 and make sure that I account for that second term there. Now, this is completely factored because I have a power of 1. So what makes this 0? It's just a letter out front, therefore 0 would be a solution. And here is one where I have a coefficient in front. So we have to take the opposite of what our eyes are seeing. So a negative 1 over 4 gives me negative 1/4 as an answer. And that would be my two answers that make that true. Anytime you start with a degree of 2 or that whatever highest power, that will indicate the number of answers that you have here. All right, next one, 9x squared minus 27x. Notice it is not equal to 0 this time. I'm going to keep this term positive, so I'm going to subtract this over and get a 9x squared minus 27x equals 0. Still, I have two terms, but I have to check to see if there's anything in common. Yes, there is. Each of them have a 9 in common, and notice there's an x in common. So I'm going to take a 9x out, figure out what's left over. I have it equal to 0. So 9x times what is 9x squared? Well, I have a 9, and one of those taken away, therefore one's left over. And 9 times what is negative 27? That's a minus 3, and here's my x that I've pulled out front. So when you distribute, you get back what you started with. So these are my factors, power of 1, power of 1. Now we find our roots or our solutions. So what number do I multiply by 9 to get 0? Again, that's just one letter out front. That would be a 0. 9 times 0 is 0. What number minus 3 is 0? Well, that is a positive 3. Therefore, 0 and 3 would be my answers for this problem. Okay? All right. Next one. We are not equal to 0 yet, but this time, again, make sure that when you subtract that term over, remember, I didn't really mention it yet, but we want to have descending powers of x's. So you want to start with your highest power, go all the way down to the number. So here, you don't want to put the x back here behind the 56. That's not going to help you out. You want to put the x right in here between those. So when I subtract that x, it's going to be x squared minus x minus 56 equals 0. Now, nothing in common there. Each of those don't have an x. I have a lot of ones going on, so there's no number in common. It is 3 terms, so I'm going to factor into 2 binomials, and I'm going to ask myself, well, if this last sign is a minus, what are the signs inside? They are a plus and a minus. I'm going to split up my x squared as an x and an x, and because I have that 1 in front, I can ask myself, what do I multiply to get 56 that I subtract to get a 1? What do I multiply to get 56 that I subtract to get a 1? I hope you're screaming again at me, 8 and 7. But I need a negative 1. So I need a minus 8 plus 7 gives me a negative 1. Therefore, these are my factors. And now we go our one step further and say, what number plus 7 is 0? Well, that is a minus 7. What number minus 8 is 0? That is a positive 8. And these are my 2 answers for that problem. Okay? All right, 2x squared plus 60x equals negative 36. It's not equal to 0, but where does that negative 36 go? It is just the number, so it's going to go on the back end. This time I'm going to add the 36 over to get 25x squared plus 60x plus 36 equal to 0. So nothing in common. There's not x's in all of them. Then I do not have a common number. The 25 kind of kicks that out with the 36. So let's go ahead and factor with 2 binomials because it is a trinomial. Last sign is a plus, so that means they are the same that match the first. So we have a plus and a plus. I need to split up 25x squared. Well, 1 times 25 and 5 times 5 are the only factors. I'm going to choose 5 with the x and 5 with the x to start off with. Factors of 36, there are plenty. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Again, I start here and work myself back. So I'm going to plop a 6 and a 6 to see if that works. Now, with this having a number in front, I have to check my outside and inside. Outside is 30x, inside is 30x. Therefore, I do believe I get my 60x. So that is my, those are my 2 factors that I have. So we have to now determine what number makes each one of those 0. Well, that doesn't give me this case or these cases over here. It's similar to this one up here where we have to take the opposite of what we're looking at over the number in front. So the shortcut is to take the opposite of what we're looking at with a constant over the 5, so negative 6/5. And notice I get the exact same thing. So I could have written that as 5x plus 6 quantity squared, and we'll see where that takes advantage of writing it that way here shortly in the next section or two. But we can also notice that it happens twice. Sometimes we refer to that as a double root. You do not have to write that twice. Negative 6/5 would just be the answer. All right, the last two. Notice 4x squared minus 25 equals 0. The last two are equal to 0. That's nice. But we only have 2 terms here with this first example. And if we have 2 terms, the idea is to think about is that a difference of squares. 4x squared would be a 2, and an x would be what I squared, and 25 I've squared 5. So it does look like it is one of those difference of squares. So I multiply or have split up exactly the same in both terms. So I need that 2x and 2x. I need a 5 and a 5, and my signs are different. One's a plus and one's a minus, and I have that equal to 0, and those are my factors. When we have powers of 1, we are done factoring. Now we have to just ask ourselves what makes this 0. With the number in front, do the opposite of what we have here over the number out front. So negative 5 halves would be 1. And the opposite of this over that gives me positive 5 halves as the other. Those are our solutions. Those are what solves that equation. Okay? And our last one has a trinomial. 8x squared plus 16x minus 10 equals 0. Notice that we actually have something in common there. And that something that is in common may look like a 4, but with that 10 back there, I believe it is just a 2 that is in common. So let's take out that 2. 2 times what is 8x squared? Well, that's a 4x squared. Plus an 8x minus a 5. And at this point again, we want to make sure that we check to see if we can go further. Since I have a power of 2, 3 terms, it's very possible that this can be factored into 2 binomials. Now, we don't want to forget that 2. We have to keep that along with us because that is part of our problem. Now, last sign is a minus, so inside we have a plus and a minus. Factors of 4, I always go for 2x and 2x to begin with. And with my 5, 1 and 5 is my number, so I could maybe put a 5 there and a 1 there. Again, I need to check the outside and inside to see if I've done it correctly. So here, outside is a minus 10x, inside is a plus 2x. That actually gives me a negative 8x. Now, do I need a negative 8x? No, I need a positive. So I have the right number, but the wrong sign. So how did we fix that? In order to fix that, I need to make this a plus and this a minus. So I'm not going to use my eraser on this program because it'll mess everything else up. So 2 times 2x minus 1 times 2x plus 5 would be my final answer because here's the plus 10 minus a 2 does give me an 8. So now I need to go down the line to figure out what are my final answers. What are the solutions that make that equation equal to 0? Well, if I just have a number out front, this is different if I have a letter. Will 2 ever equal 0? The answer is no. 2 will never equal 0. So this doesn't kick out an answer. The only answers are going to come from inside here. So we take the opposite of what our eyes are looking at over that would give me 1/2. Take the opposite of what we're looking at as the constant over the 2 would give a negative 5/2. And those are my 2 final answers for that problem. Okay, so 2 different ideas here. Factoring is looked at all throughout, but solving the equation would be the second idea, making sure that you go one step further after you factor a problem to find the answers that make that true. And the reason we're doing this is because it's going to help us out when we start graphing polynomials here in the next couple sections. So until next time.